Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and this video is the first video dealing with functions. Functions define relationships between variables. We're going to limit our study to just two variables. There could be more than two variables. But in these sections, we're just going to look at two variables. And one variable is called an independent variable, and the other one's called a dependent variable. And functions can be expressed as equations, as graphs, as verbal statements, as a set of ordered pairs. But what I want to focus on in this video is functions that are expressed as equations. So if we take a look at this example here, it's telling me that y is equal to 3 times whatever x is equal to plus 4. So the value of y depends on the value of x. For that reason, we call x the independent variable. And we call y the dependent variable. The value of y will depend on the value of x. And in order for this, any equation is a relation, but in order for it to be a function, the rule or the definition says that for any value of x, there's only one corresponding value of y. In the next video, I'll talk about relations that aren't functions, but in this video, we're just going to concentrate on functions. When you are working with functions, you're going to see function notation. So function notation looks like this, f of x. All along I've been telling you when you see things beside each other, it means multiplication. That's not the case when we're dealing with functions. This means a function of x. So it's like the y. I'm replacing y with f of x. It means the same thing. I'm saying a function of x. So instead of having y equals 3x plus 4, the notation that we can use is f of x is equal to 3x plus 4. And it means the same thing as when I had y equals 3x plus 4. We understand it to mean the same thing. So realize that this does not mean multiplication, it's function notation. Typically when you're dealing with function notation, you usually use f or g or h as your function letters. And then we often use x, but we also are going to use some other variables in some of these examples, because in the real world, x isn't always going to be in your formulas. It's going to be other variables. So we will look at that. But understand what this means, and then I want to talk about how you evaluate functions. So looking at this example, if I said, given this example, what is f of 1? What that's asking me is what is the value of the function when x is equal to 1? So you simply put 1 in for x and evaluate. So f of 1 would be 7. I could put any value in there. I could put a negative, a positive. If I put negative 2, I simply put this value in wherever there's an x. So that would evaluate to negative 2. If I had f of x equals x squared plus 3x plus 2, again, I can evaluate this function for specific values of x. So for example, I could find f of negative 1 by simply putting a negative 1 in wherever there's an x. So I'll have negative 1 squared plus 3 times negative 1 plus 2. Negative 1 squared is 1. 3 times negative 1 is negative 3 plus 2. And that is equal to 0. Sometimes when you're asked to evaluate functions, it's not a single number that you're evaluating. For example, I could have a letter. Let's say I had f of a. That simply means I put an a instead of an x. I just evaluate it when x is equal to a. That's what it's asking me. So f of a would be a squared plus 3a plus 2. I could have f of 2a and be asked what f of 2a is. So the expression in here is not necessarily going to be a single number or a single variable. It can be an expression. So I'm going to do examples of that so you understand the whole idea. So f of 2a would be 2a squared plus 3 times 2a, because wherever there's an x in the original function, I'm going to replace it with the 2a. So that would be equal to 4a squared plus 6a plus 2. So that's what f of 2a is equal to. Let's take a look at another example, and I'm going to use a variable other than x for our independent variable. I'm going to use t, just so that you get comfortable with different independent variables, because a lot of the formulas and functions you will be working with in the real world will be different variables other than x. But it means the same thing. And what I want to show you is things to be careful about when you are evaluating functions. So let's start off with f of a. Similar to what I did in the last example, I put an a in for my independent variable, so it's going to be a squared minus 4a plus 5. If I was asked to evaluate f of 2a, we're going to put a 2a in wherever there's a t. So 2a squared minus 4 times 2a plus 5. That simplifies to be 4a squared minus 8a plus 5. What I want you to see is that that is different than 2 times f of a. Here the 2 is included in with our independent variable. Here the 2 is outside of the function. So what this means, it just means 2 times f of a. And we already know what f of a is. F of a will be a squared minus 4a plus 5. So when we evaluate that, we will have 2a squared minus 8a plus 10. So you can see that they're different results. So you need to understand when you see mixed expressions and you see things outside as well, they mean different things. Let's take a look at an example if we had an expression that had a sum or a difference in it. So now our independent variable is actually an expression, but we still follow the same procedure. We replace our independent variable with this expression. So f of a plus 2 will be, here's our independent variable, which we replace with a plus 2 squared minus 4 times, there's our independent variable, we replace it with a plus 2 plus 5. We can expand this. This is like a plus 2 times a plus 2. Remember, we just can't square each term, we have to FOIL. So we're multiplying two binomials. So we'll get a squared, I'll just show you what I'm doing, a plus 2 times a plus 2. So a times a gives me a squared, plus the outside 2a and the inside 2a, that gives me plus 4a, times, or plus 2 times 2, which is 4. We can distribute, so minus 4a minus 8 plus 5, and that simplifies to be a squared plus 4a minus 4a is gone. 4 plus 5 is 9, minus 8 is plus 1. So that would be f of a plus 2. That would be different than f of a plus 2. So what that is just what f of a is, and then I add a 2 onto the whole expression. So because that plus 2 is not included inside the brackets, I deal with that outside of the function. So this would be equal to a squared minus 4a plus 5. So there's my, this whole thing here, this expression is my f of a, and then I go plus 2. I can simplify this. And you can see these are very different. I'd like to do one more example because you might see something like this in your homework. And I want you to understand how to evaluate something like this as well. So we're sticking with that same function, f of t is equal to t squared minus 4t plus 5. And when you're asked to evaluate, they might say evaluate this, f of t plus 2 minus f of t plus 2 in brackets. Those are very different things. So let's talk first of all about what f of t plus 2 is. So this is going to be equal to, wherever there's a t, we're going to replace it with t plus 2. So it'll be t plus 2 squared minus 4t, instead of t we put t plus 2 plus 5. So this, I need square brackets because I've already used round brackets inside. So this represents f of t plus 2. From that we're going to subtract, again I'll put my square brackets, f of t, because this plus 2 is outside of the function, so f of t is just t squared minus 4t plus 5. So that's our f of t there, and then we go plus 2. Now we have to evaluate this, combining like terms and get rid of all these brackets. So t plus 2 squared, remember, is t plus 2 times t plus 2. I'm going to FOIL that. So I will get t squared plus 4t, 2t plus 2t plus 4. I will distribute this negative 4, so that will be minus 4t minus 8 plus 5. Minus, the only thing I can really do to simplify, I can drop in these brackets now because I'm just adding. So it's going to be t squared minus 4t plus 5 plus 2. And I could have evaluated or simplified it further in that step. But since I have to do this one, I'm just going to take it step by step. So combining like terms, I'll have t squared. I've got 4 plus 4t minus 4t, so it's gone, it's a 0. And then I have 4 plus 5 minus 1, or minus 8 gives me plus 1. So this will be t squared minus 4t plus 7. Now I'll drop the brackets, so I'll have t squared plus 1. But I have to distribute, I don't drop them, I distribute that negative. So minus t squared minus minus gives me plus 4t minus a 7. And now I can combine all my like terms. T squared minus t squared is 0. I'll have 4t plus 1 minus 7 will be minus 6. So don't give up if you see something like that. Just do it bit by bit and keep all your brackets, and then just start getting rid of those brackets as you carry through the operations. Combine like terms and you should end up with something that doesn't look quite as bad as what you started with initially, but it's important to understand that these two are very different things. So you'll probably see questions like this. So that concludes our first video on functions. There's going to be another one following, and it's going to cover domain and range. It's going to cover graphical representation of functions, and it's also going to look at piecewise functions. So a few other topics to deal with functions that will be on the next video. So practice with this, and when you're ready, I'll see you on the next video.